JWST has uncovered galaxies so ancient they upend our picture of the cosmos, and the number one find will make you rethink starbirth itself. Stay till the end for the most mind-blowing discovery. Astronomers first thought GNZ11 was the farthest galaxy ever seen, but JWST's sharper eyes revealed it to be a bustling, mature system from just 400 million years after the Big Bang. The galaxy shines with a surprising amount of heavy elements, suggesting that star formation and supernova enrichment happened far more quickly than many models predict. Its compact core glows intensely in infrared, hinting at a dense concentration of young, massive stars hidden behind dust. Researchers estimate a star formation rate comparable to a modern starburst galaxy, yet its age places it at a time when the universe was still in its infancy. This paradox forces theorists to reconsider how quickly galaxies can grow and enrich themselves. Up next, Rank 9 showcases a galaxy whose sheer size at such an early epoch will astonish you.
Imagine a galaxy that might be the most distant object ever observed, and you have HD1, a candidate pushing the redshift frontier to around Z is almost equal to 13.5, or roughly 330 million years after the Big Bang. If confirmed, HD1 would be emitting light from a time when the first stars were just igniting, making its brightness all the more puzzling. Its apparent luminosity suggests either an extreme burst of star formation, or perhaps an early active galactic nucleus powering a nascent black hole. Some analyses propose that gravitational lensing could be amplifying its light, but even with magnification the intrinsic brightness remains astonishing. The discovery forces astronomers to ask how such massive structures could assemble so quickly, and whether our models of early dark matter halos need revision. Stay tuned for Rank 8, where a hidden galaxy reveals a secret about early universe dust.
Surprisingly, CEERS 93316 appears as a massive, rotating disk galaxy at a redshift of roughly 4.6, a time when most galaxies were expected to be chaotic and irregular. JWST's infrared imaging captured clear spiral-like arms and a well-ordered velocity field, indicating that orderly disk formation happened much earlier than conventional simulations suggest. The galaxy's stellar mass is estimated at several hundred billion solar masses, rivaling the Milky Way today, yet it existed when the universe was only a tenth of its current age. Its existence hints that gas inflows and angular momentum retention were already efficient in the early cosmos. Some scientists argue that observational biases might favor the brightest, most ordered systems, but the data still challenges the notion that early galaxies were uniformly turbulent. Next, Rank 7 uncovers a hidden gem whose faint glow tells a story of early star-forming clouds.
Hidden within the deep field of SMACS 0723, the faint source J001 emerged only after JWST's long-exposure observations, revealing a tiny galaxy at a redshift near 9.5. Its low surface brightness initially escaped detection, but the telescope's unprecedented sensitivity uncovered a compact clump of star-forming regions enshrouded in dust. The galaxy's spectrum shows strong Lyman alpha emission despite the expected neutral hydrogen haze of that epoch, suggesting that early pockets of ionized gas were already carving out transparent channels. Estimates place its stellar mass at just a few million suns, making it a true dwarf galaxy that could represent the building blocks of larger systems. This discovery underscores how many early galaxies may remain invisible without deep, infrared surveys. Up next, Rank 6 brings an unbelievable find that seems to host a supermassive black hole far too early.
Unbelievable evidence points to JADES GSC130 housing a supermassive black hole less than 300 million years after the Big Bang, a period when such massive objects were thought to be impossible. JWST detected broad emission lines and high-energy radiation indicative of an active galactic nucleus, despite the galaxy's modest stellar mass. If the black hole's mass truly approaches a few hundred million suns, its growth rate would require either extremely efficient accretion or exotic formation pathways, such as direct collapse of massive gas clouds. Some researchers caution that alternative explanations, like a dense star cluster mimicking AGN signatures, cannot be ruled out. Nevertheless, the observation forces a re-evaluation of black hole seed models and suggests that the early universe may have nurtured rapid black hole growth more commonly than previously believed. Coming up, Rank 5 reveals a galaxy where few people know the story of its unexpected metal richness.
Few people know that Glass Z12, a galaxy observed at a redshift of about 12, contains surprisingly high levels of heavy elements like carbon and oxygen, despite forming only 350 million years after the Big Bang. Spectroscopic data from JWST shows emission lines that indicate rapid enrichment from massive stars that lived and died within a few million years. This metal abundance challenges the conventional view that early galaxies were almost pristine, composed mostly of hydrogen and helium. Some models suggest that intense starburst activity, possibly triggered by mergers, could accelerate chemical evolution, while others propose that early population 3 stars might have contributed more metals than previously thought. The galaxy's compact size, combined with its enriched composition, offers a unique laboratory for studying the first cycles of star formation and feedback. Next, Rank 4 presents an incredible system that appears to be forming stars at a rate far beyond expectations.
Incredible observations of SPT 041847 reveal a star formation rate exceeding 500 solar masses per year, an intensity that dwarfs typical galaxies of its era at redshift 6.3. The galaxy's infrared glow, captured by JWST, suggests a massive reservoir of cold gas fueling a prodigious burst of new stars, while also emitting strong nebular lines that hint at dense, ionized regions. Some estimates propose that this starburst could be the result of a recent merger, funneling gas into the core and igniting rapid stellar production. Yet the sheer scale of the activity raises questions about how such massive gas supplies could accumulate so early, and whether feedback from supernovae and possible black hole activity might soon quench the frenzy. Up next, Rank 3 offers a stunning glimpse of a galaxy whose shape defies expectations.
Stunning images of MACS 0647 JD show a remarkably elongated, lens galaxy at a redshift around 11, its light stretched into multiple arcs by a foreground galaxy cluster. Despite the extreme distance, JWST's resolution resolves clumpy star-forming knots within the arcs, indicating that even at such an early epoch, galaxies could develop complex internal structures. The magnification factor, estimated at over 20 times, allows astronomers to study the galaxy's stellar populations in unprecedented detail, revealing a mix of young, hot stars and older, more evolved ones. This suggests that star formation began even earlier than the observed redshift, potentially pushing the onset of galaxy assembly back to the first few 100 million years. The discovery also demonstrates the power of gravitational lensing combined with JWST to probe the faintest corners of the early universe. Coming up, Rank 2 highlights a remarkably compact galaxy that challenges size expectations.
Remarkably, NIRCam JADES 001 appears as a tiny, ultra-compact galaxy at redshift 7.2, spanning only a few hundred parsecs yet packing a stellar mass comparable to a dwarf galaxy. JWST's imaging reveals a bright central core surrounded by faint, extended emission, suggesting a dense burst of star formation confined to a small region. Such compactness challenges theories that early galaxies should be more diffuse due to turbulent gas dynamics. Some scientists propose that rapid cooling and efficient angular momentum loss could produce these dense knots, possibly serving as seeds for later galaxy growth. The galaxy's high surface brightness also makes it an excellent candidate for studying the ionizing photon budget that contributed to reionization. Finally, Rank 1 delivers the most astonishing early universe galaxy JWST has uncovered.
Finally, the most astonishing discovery is GNZ 131, a galaxy that may reside at a redshift close to 13, placing it just 300 million years after the Big Bang and potentially making it the earliest confirmed galaxy to date. JWST's spectroscopy detected faint Lyman alpha emission and a continuum break consistent with such an extreme distance, while the galaxy's luminosity suggests a surprisingly mature stellar population already in place. If the redshift holds, this object forces a radical rethink of how quickly the first massive galaxies could assemble, form stars, and enrich themselves with heavy elements. Some analyses argue that line-of-sight contamination or lensing could affect the measurement, but the data remains compelling. GNZ 131 stands as a beacon from the dawn of cosmic history, reminding us that the universe's earliest chapters are still being written before our eyes.
We've journeyed through a decade of astonishing early universe galaxies, each one stretching the limits of what we thought possible only moments after the Big Bang. These discoveries not only rewrite textbooks but also hint at the hidden complexities of cosmic evolution, reminding us how much more there is to learn. If you enjoyed this deep dive, subscribe so you don't miss the next mind-blowing list we release every week. Which of these 10 galaxies left you the biggest impression? Share your thoughts below, and if you liked the video, give it a thumbs up to help others find it.